dilation. Okay, getting into solving quadratics. So remember, our first method is factorizing. So this is where we are given a quadratic in this form, and we want to solve it to find our x-intercepts, or when the equation is equal to 0. So, if we're asked to graph this quadratic, our first step, of course, would be to find the x-intercept, which we would let x equal 0, which is, of course, going to give us just our vertical shift at the end, -3. Our second step is to find the x-intercepts, which means, of course, we need to solve our equation using the null factor theorem. So, it's not in the slides here, but I thought it would be helpful for us to really quickly go over a more in-depth of factorizing. There are a few different ways that you can conceptualize factorization. So if you learnt this a different way, or if you understand it in a different way, you use a different method, that's completely fine as long as it works for you. The method that I learnt was what we called the ACB method. So we need to look at what the AC and the B, remember we're considering our general form, ax squared plus bx plus c. So our a here is 2, our b is -1, and our c is -3. So if we multiply our a and our c values together, we are going to get -6. And if we just put our b value in there, now what we need to do is we need to think of two numbers that are going to, as I've shown up here, are going to multiply together to equal -6, and are going to add together to equal -1. So we need to go through some of the possibilities. So what two numbers multiply together to get -6? You might think perhaps -3 and 2. They get -6, and then -3 plus 2 gets -1, which is exactly what we wanted. So we now know that the two numbers that we want to substitute in are -6 and -1. Our next step is, of course, to, oh no, sorry, -6 and -1 are -3 and 2. So our next step is to sub these two numbers in for the middle b value. So remember, once you've found your two numbers, so ours were -3 and 2, sorry, -3 and 2, what we want to do is we want to substitute those two numbers into our, in place of our middle term, and add x to them. And of course this works because -3x plus 2x equals -x, which is what we were subbing in for, so it's still equal, but this allows us to factorize it. Okay, now what we want to do is we want to factorize. So what I'm going to do is I'm going to put my 2x at the front, and then multiply that by x plus 1, because this is going to give me my 2x squared plus 2x. What I'm going to do next is I'm going to put outside -3 outside of x plus 1, because that is going to give me my -3x take 3. So as you can see, this is all equal if we expand it. But the important thing to take note of is that the two brackets have the same things in them. Because now that they have the same things in them, we can group all of these numbers together. It's just kind of like saying x plus 1 is a like, not a like term, sorry, it's like a common factor to both of these. So we can kind of smash those two x plus 1's together and then put our other two numbers together, of course, because x plus 1 is a common factor for both of them, so we can kind of pull it out, and then 2x take 3 is kind of what we're left with in the remaining brackets. And then this is, of course, what we're left with up here. So I hope that was useful for you guys. I know it's kind of easy if you don't practice enough to figure out how to factorize quadratics. Especially the non-monic ones like this one here. Remember, like a non-monic quadratic is where the coefficient of the x squared is something other than 1. So here it's 2x squared, which makes it a little bit trickier. And then, of course, we need to apply our null factor theorem. So we're going to let both of these factors equal 0, and then they're both now just linear factors. So we can just rearrange to isolate x, which gives us x equals 3 on 2, and x equals -1. And this tells us our x-intercepts occur at 3, 1, 2, 0 and -1, 0. So graphing this is what we're going to get, right? -1, 0, -1.50, and then the y-intercept that we found.